This question is a follow-up to the one we did previously where you classified a few of your galaxies. This week, we're asking you to combine those classifications with what you've learned about galaxy formation and evolution to talk about what has happened to a couple of these galaxies. Remember that there are four important processes that play a role in galaxy evolution: gravitational collapse, spin, star formation, and collisions. By knowing the type and color of a galaxy and looking at an image of it, you should be able to make conclusions about the last three of these. You should choose two of your galaxies to describe here. If you've identified two that are different types of galaxies, you should choose those. Also, if you have any corrections to make on your classifications from the earlier assignment, make sure you do those before you try going ahead with this question. When galaxies are forming, the amount of spin they have plays a big role in how they turn out. To form a spiral or lenticular galaxy, the gas has to have a systematic spin rate. In elliptical galaxies, the stars are moving in more random directions, so they have very little total spin. Irregular galaxies are more of a mixed bag. Some have very random structures with no sign of a total net spin. However, if you see something that looks like a disk structure, that suggests there is a significant amount of spin available. So use the types of each galaxy and the structures you see in them to tell you how much spin they have and explain your answers. Stars form when the gas in a galaxy is compressed to high enough density that gravity can cause it to start collapsing in on itself. For this to happen, there has to be enough gas concentrated in a small region. Depending on the type of galaxy, the history of star formation can be very different. When an elliptical galaxy first forms, most of the gas is converted into stars, giving a big burst of star formation early in the galaxy's history and then very little afterwards. On the other hand, in spirals, the rapid spin means that some of the gas gets spread out into a disk, preserving it for later star formation. The spiral arms that distinguish spiral galaxies are produced by density waves within that gas and the ongoing star formation that comes with that. Of course, if a spiral galaxy uses up its gas, then it will still have its disk shape, but it will no longer be making new stars. That will turn it into a lenticular galaxy. So in lenticulars, star formation probably continued for longer than in ellipticals, but eventually it stopped. In irregulars, there is more variation in their histories, and you may have to use other clues besides shape and the presence of spiral arms. For example, the color can be an important clue. Bluer galaxies tend to have more star formation, since young, high-mass stars are the bluest stars we see. The one exception to this happens when you're looking through a lot of dust. So if you see a galaxy with dark streaks across it, that may mean there's dust making the galaxy look redder. Also remember to use the color defined in the table rather than in the picture, since the picture colors aren't standardized. Another sign you can look for are ionization nebulae. If you've got a very high resolution picture, you can look for these bright pink regions, which show active star formation happening in a galaxy. So use all of this information to decide if each galaxy is still making stars or not. Make sure you explain how you got to your conclusions. The last process to look for is collisions, and you may not see any evidence of these. However, there are a couple of things that might indicate recent collisions in a galaxy. First, just look at the shape. If it looks like a standard spiral or elliptical shape that's been distorted, especially if there are streams or tails of stars extending out towards another galaxy, that would be a clear indication of a recent or even ongoing collision. You might also see a neighboring galaxy that has a tail of gas or stars stretching out towards the one you're observing. That counts too. Other indications of a collision are within the galaxy you're observing. Sometimes you can even see evidence of two bulges within a single large distorted galaxy, a clear sign that this is a recent merger of two galaxies. You might also see clouds of dust cutting across an elliptical galaxy, showing that it's had an encounter with something dustier. And you might see something that looks like a clear spiral, but which has a very red color. That could be telling you that this is a starburst galaxy and it's going through very rapid star formation, triggered by a recent collision. If you see any of these or any other indication that suggests to you that a collision has happened, describe it and make sure you explain how you can tell this galaxy has collided.